Hello guys, welcome back to this channel. This is solved problem number 2, how to plot shear force and bending moment diagram for this particular beam. So we have this beam which is subjected to a concentrated load of 60 kilonewton and a uniformly distributed load of 2 kilonewton per meter. We also have a moment, counterclockwise moment of 180 kilonewton meter acting 20 meter from the left support. So the first task is to determine the support reaction at A and support reactions at B. So as usual, before calculation, we'll assign sign conventions. We'll assume all forces acting to the right of x-axis to be positive. We'll also assume that all forces acting vertically upward to be positive and all counterclockwise moments to be positive. So using the first equation, summation of forces in the x is equals to 0. We do not have any horizontal force on the beam, hence the reaction at AX will be 0. So RAX will be 0. Using second equation, summation of forces in the y is equals to 0. We have RAY plus RBY minus 60 kilonewton minus the reaction due to this uniformly distributed load, which will be 2 kilonewton per meter multiplied by its corresponding length 10 plus 10, 20 meter. So RAY plus RBY will be 100 kilonewton. We have one equation and two unknowns, hence we will use the moment equation to determine either one of RAY or RBY. So by taking moment at point or support A, we have RBY multiplied by its corresponding moment arm 30 meter plus this counterclockwise moment 180 kilonewton minus this 60 kilonewton makes a clockwise moment, so minus 60 kilonewton multiplied by 10 meter minus this the moment created by this uniformly distributed load, so minus 2 kilonewton per meter multiplied by 20 into its moment arm 20 over 2 plus 20 meter. So RBY will be 54 kilonewton. Substituting this into the previous equation, RAY will be 46 kilonewton. So let's check. So upward force must be counterbalanced by downward force. Upward reactions are 46 kilonewton plus 54 kilonewton. It will give us 100 kilonewton. And the downward forces are uniformly distributed load 2 kilonewton, which is acting on 20 meter, and the 60 kilonewton, it will give us 100 kilonewton. So it's okay. We can proceed on to plotting shear force and bending moment diagram. So remember that always shear force and bending moment diagram start from neutral axis and end in neutral axis. Their value starts from 0 and end in 0. So at point A, at support A, at x is equals to 0, we have a reaction of 46 kilonewton. So from 0, it will go to 46 kilonewton. On this span, we do not have any force. There is no force. Hence, the shear force will be constant. 46 plus 0, it will be 46. At x is equals to 10 meters, there is a downward force of 60 kilonewton. Hence, it will be 46 minus 60. It will be minus 14 kilonewton. There is no force on this span, so the shear force will be constant again. At x is equals to 20 meter, there is a uniformly distributed load. So due to this uniformly distributed load of 2 kilonewton per meter, the shear force diagram will no longer be constant. It will not be constant, hence it will be reduced by an amount of 2 multiplied by 10, 20 kilonewton. Hence minus 14 minus 2 times 10, 20, and we'll have minus 34 kilonewton as support B. So at support B we have a reaction RBY of 54 kilonewton. So minus 34 plus 54 we will have 20 kilonewton. On the final span, due to this uniformly distributed load of 2 kilonewton multiplied by 10, we have a positive, a downward negative force of 20 kilonewton. So positive 20 kilonewton minus negative 20 kilonewton, shear force will be 0. Next task will be to plot bending moment diagram. So at x is equals to 0, we have only a line, so 46 times x, which is equals to 0, area of a line will be 0. So at x is equals to 10, at x is equals to 10 meter, the bending moment will be area of region A. Area of region A will be 46 multiplied by 10, so we'll have 460 kilonewton meter moment. Notice that the bending moment line is a straight line since shear force distribution is constant. At x is equals to 20 meter, at x is equals to 20 meter, it will be area of region A plus area of region B. But notice that area of region B is negative. So area of region B is minus 14 times 10, it will be negative 140. Subtract that from 460, we'll have 320 kilonewton meter. Still, the bending moment line is a straight line since shear force distribution is constant. At x is equals to 20, we have also another variable, which is a moment of 180 kilonewton. So due to this 80 kilonewton, the bending moment will be 320 minus 180, we have 140 kilonewton meter. At x is equals to 30 meter, x is equals to 30 meter, we'll subtract the area of region C from the previous moment. So area of region C will be 1 over 2 base times height for this triangular region, and for the remaining rectangle region we have 14, negative 14 times 10, so we'll have minus 100 kilonewton meter. Notice that the distribution of this bending moment is curved since this shear force distribution is not constant, so it will be a curve. And finally, at x is equals to 40 meter, we have area of this region, have 10 times 20 will have 100, so minus 100 plus 100, it will give us 0. So if you find this video helpful, don't forget to subscribe, and please like and share these videos to support this channel. I'll see you in the next videos. Thank you.